Hello guys, welcome back to TechDose, and in this video we will look at zero array transformation 3 problem, which is from LeetCode number 3362. Let's now read the problem statement. In this problem you are given an integer array nums of length n and a 2D array queries where queries at I represents a range from Li to Ri, both inclusive. Each queries at I represents the following action on nums. You need to decrement the value at each index in the range of Li to Ri in nums by at most 1. The amount by which the value is decremented can be chosen independently for each index. That means either you will decrement by 0 or you will decrement by 1, because you cannot decrement by any more than value 1, and we are dealing with only the integer numbers. Which means that if you have a set of items, let's say 2, 1, 0, 2, and the indices are 0, 1, 2, 3, if I say that the L and R value are, let's say LR values are 0, 2, then you can decrement only in the range of 0 to 2 wherever required. So since I want to reach like a zero array is an array with all the elements equals to 0. I want to make this array finally into a zero array where all the values are 0. So when I'm processing a query, then I will want that all the values in this range should be minimized as much as we can. So I'll try to subtract 1 from this 2 and make it 1. Subtract 1 from this 1 and make it 0, but don't do anything to this 0, otherwise it will go to a negative number, and leave it as it is, right? So this is what the condition 2 is saying, where in this entire range of L to R you can choose certain items to be decremented and you can leave certain other items. Now we need to return the maximum number of elements that can be removed from the queries such that the nums can still be converted to a zero array using the remaining queries. If it is not possible to convert nums to a zero array, we need to return -1. So the meaning of this line is, given q number of queries, here in this example 3 number of queries, we need to convert this nums into a zero array where all the elements are 0 in the array by using minimum number of queries from the queries array. So in this case, if I can get the job done by only 2 queries, then my answer will be 1, because total number of queries are 3, and if I can convert this given nums array to a zero array by using only 2 queries, then my leftover query is 1. That is redundant query, right? So if you look at this example, we have the indices 0, 1, 2 with the value 2, 0, 2. If I apply the first query from 0 to 2, then I can select the 0th item to be reduced by 1, the first item to remain as it is because I want to reach to a zero array, and the second item to be reduced by 1. Again, if you choose to apply 0 to 2, you can make this 0, this will remain as 0, and this can be made as 0. So you reach to a zero array by just applying 2 queries, and you don't need the third query. And that is why in this case you can remove maximum 1 query in such a way that the rest of the queries will convert the given nums array to a zero array, right? So I think the problem statement is clear. If you look at the third example, in this case, given this array having 4 items, you just have a single query. If you apply this from 0 to 3, then you cannot decrement by more than 1 value, right? So is this a zero array? No, this is not a zero array, and you have run out of all the queries. So if you cannot convert the nums array to a zero array, then we need to return -1 in such cases, okay? If you look at the constraint, the nums.length, that means the number of items, is maximum 10 to the power of 5, and each of the item is within the integer range, which is 10 to the power 5 to 0. So these are all positive numbers, you can say. Queries length is maximum 10 to the power of 5. So if you end up writing a QN algorithm, then that is not going to pass, because 10 to the power 5 times 10 to the power 5 is 10 to the power 10, which is well above your 10 to the power 8, which is the standard for 1 second. So since you want to solve it within 1 second, your computation should be less than 10 to the power of 8. Now each of the query length exists in pair, which is L, R, right? And L, R are always within the bound of the length, that is from 0 to n-1. It will range from 0 to n-1. So I hope the entire problem statement with the constraints are clear. Now let's look at an idea for solving this problem. In this case, we will try to apply the greedy query selection. What is the meaning of it? Let's say that we are given a bunch of indices from 0 to 5. I don't care about the values. But if you are given two queries Q2 and Q1 where they are completely overlapping, that means Q2 is completely a subset of Q1. Q2's range is from 1 to 3. Q1's range is from 1 to 4. So you can say that they are completely overlapping and Q1 is a larger query. Then in such case, if I have to select an order, that means which query will you choose first, then I will always select the larger query over the smaller query. So first I will try to apply Q1 and then I will try to apply Q2, because there can be multiple scenarios. One scenario can be you need both the queries, so in that case order will not matter. In one other case, you may just require Q2, so selecting any of them will be fine. But if you can get the job done by just Q1, then that can create a problem. Like, let me show you an example here. If you take the items from, let's say, 0 to 5, that means you have 6 items. Now if you apply query 2 here first, okay, so query 2 is saying from 1 to 3 you can apply the zero array transformation. So I will reduce this 1 to 0, this 0 will remain as it is, and this 1 will be converted to 0. Is this a zero array? This is not a zero array because you are still left with 1. So can we make this 0? If you apply Q1 again, then this value can again be made as 0, rest all values will remain as it is. So you have reached to zero array in 2 steps by first using Q2 and then followed by that you have used Q1. Okay, but our goal is, one of the goal is to reach to a zero array. The second goal, which is the important one, is to minimize the number of queries we have used. Now if you consider using Q1 here, just Q1, then you will be able to convert all the items from 1 to 4 directly into a zero array in just one step. So you will not even be using query 2, and therefore you have saved one query, right? So in this case the answer should be 1 and not 0. If you use Q2, Q1, the answer will come as 0. If you just use Q1, then you have saved one query, so the answer will be 1. And that is why this is the optimal approach. Q2, Q1 is not the optimal approach. And why this worked? Because we applied Q1 first. Now if you give a counter example, that let's say that this value was 0, then if this fourth value happened to be 0, let's say it was not 1, it was 0, then applying any query will be absolutely fine. Okay, even if you apply the larger query, it will not affect the answer. Applying the smaller query will also not affect the answer, right? Both will give you 1 as an answer. But my logic is, if you apply the larger query, it will never give you wrong answer. But if you apply a smaller query before the larger one, then it may give you a wrong answer. Okay, I can also create other test cases where you will require both the queries. Like, what if I make this one as 2? Then in such case, if you apply query 1 first, then all these values will be 0, but this one here at index 3 will still be maintaining as 1. And again, if you apply query 2 on top of it from 1 to 3, then this one will become 0, right? So in this test case, applying anyone in the beginning like Q2, Q1 or Q1, Q2 will have no effect. So if you apply the larger query before the smaller one, where the smaller one is a subset of the larger one, you can say, right? That means they are completely overlapping. Then in such case, applying the larger one first and then the smaller one, if required, apply this only if required, will never give you a wrong answer. It will always be optimal. So I hope you have understood this. Always greedily pick the larger of the two fully overlapping queries. Okay. Now if you consider a general example, then I have shown for again 6 items. I have masked all the values, that A, B, C, D can be anything. If you have a value 1 here, then how will you reduce it to 0? Which query will you choose? Now you know that you have to choose query 2 looking at these options Q1, Q2, because Q1 is a subset of Q2. It is entirely fully overlapping, and Q2 is a larger query. That is why I will be applying Q2 operation here, which will always be optimal. So I hope you have understood how to apply the greedy query selection and why the larger query works. Now the next important point is we should use the pre-included queries first. Okay, what is the meaning of pre-included queries? So let's say that we are given an array having 6 items, and in this case the queries are already drawn. Okay, now I have to solve this entire solution either by moving from left to right or moving from right to left. You cannot hope to randomly solve it, right? So if you are solving from left to right, the requirement to convert the items to 0 will come for the beginning indices rather than the later indices, isn't it? It will come in order. So since the indices are getting converted to 0 if possible, in order from left to right, you should always sort the queries in the ascending order of the indices. Okay. Now there are two indices in the query, L and R. L is the start of the query and R is the end of the query. So if you carefully consider, then I should always sort it based on the start point, not based on the end point, because when I move my pointer, my I pointer or the position pointer from left to right, then I always want the guarantee that I will be seeing the queries starting later at some later index. But if you sort it based on the endpoints, like let's take this example S1 E1 and S2 E2. If you sort it based on the endpoint, then you will find that S2 E2 will come first and S1 E1 will come later. S1 E1 will come later. So your position pointer will miss its usage at S1, which occurs earlier than S2. Okay, and it will move to S2 thinking that S1 itself is not present. There is no query to reduce this value to 0, and that will give you a wrong answer, right? So I always want to guarantee that whenever I want to reduce an index to 0, then I want all the available query options for that particular index, and that is only possible if you sort by the start point, not by the end point. Okay, that same logic was applied in even the merge interval problem. If you have solved that, there we will be using sorting by start point, not by the end point. The same logic is applied in this case as well. Okay, so we can apply the greedy pick only on the sorted queries, right? Because we are solving it from one side to the other. In our case, I will be solving from left to right. Now let's say that I am present at this index 0. Now at this case, I want to convert this 1 to 0. Is it possible? You look that a query is available Q1. So if you use this query Q1, then you can convert this 1 to 0. That is absolutely fine. But what is the validity period of this Q1? Q1 will be valid until index 3. Until index 3 comes, Q1 will be valid. From 0 to 3, Q1 will be valid, right? Now, if you move to the next item, then I want to convert this 2 to 0. So if I want to convert this 2 to 0, first of all, I will not be including this Q2, but I will try to reuse the query which I have already used, because I want to minimize the usage of the queries, right? Because this value could have been 1, and in such case, if I want to convert this 1 to 0, then simply I can do that by the Q1 which I have already included for index 0 and not include this Q2, isn't it? So that should be my approach. Like whatever query have been used and it is still valid for this particular index, ith index, I will try to use that rather than including a new query, whatever long it may be, howsoever long it may be, right? So in this case, I can use Q1 and I can reduce this 2 to 1 by using Q1. But there are no other available queries with us which we have already included. Now I will start looking for, are there other options? So yes, there is Q2. So if I use Q2 as well, which is valid till index 2, then I can convert this 1 to 0. So including Q1, Q2 will make this index 1 value go to 0, and that is fine. Okay, this is how it works. Now if I go to the next index 2, then I see that both Q1 and Q2 are valid. Okay, both of them are valid. So which one should we include? You look that Q3 is also starting at index 2. So will we include Q3? Well, absolutely no. As you know that if reuse is possible, I will try to reuse. So maybe I will be going with Q1. Okay, I will be reusing one of them. So I can reuse Q1 and convert this 2 to 1. And I can reuse this Q2 and convert this 1 to 0. And this value can be converted to 0 without even including this Q3. That is fine. Now once you move forward, then you look that this Q2 has become invalid, so I have to remove it, and then you move forward to this index 3. When you come here, you look at, is there any query valid? Yes, Q1 is still valid, so I can convert this 1 to 0 using Q1. And if you move forward, Q1 will become invalid, so I will be removing it from our available queries. And I'm at 4. Now at 4, the value is already 0, no need to be reduced. At 5, you see that there is a query which I can use, because there are no other available queries present. So I can use Q4 which is valid till 5 to convert this 1 to 0. And before moving forward, I have to remove this Q4 because its validity has ended. So in this case, we converted this given array to a zero array without using Q3. We had used Q1, Q2 and Q4. So the number of queries which were not used is 1. Therefore, the answer should be 1 in this particular example. So I hope the idea is clear, right? Now in this case, if you notice, each of the query will be having 4 states. Okay. Now when we parse from left to right, then the query can be unseen, right? Like let's say if I am at index 1, then what happens to this query Q3 have not been seen by S. Okay. So whenever I am at an index where a query is starting to the right hand side of that index from any other index, then that is already in unseen state. Okay. Now whenever we arrive at a query, let's say at 2 we have arrived at a query, then I will try to see whatever queries are starting at this particular index and try to keep them in a pool. Okay, which I will be showing you on the next slide. We will try to keep them in a pool so that if it is required in future, I can use them, isn't it? So now that query which was unseen has now gone to a seen state, but it has not been used yet. It has just been seen but not been used. Now at any point of time, like if the value here was let's say 1, at any point of time, we may be required to use the query from our available pool. So in this case, if I do that, if I use one of the queries from the available pool, then that moves from seen and not used state to used state. But it is still valid. It will only become invalid when we move to an index to the right of the end point of the given query. Then that query will move to an invalid state, right? So these all states we have already seen in this idea dry run, right? This is not a full dry run. And I hope you have understood what these 4 states mean. Okay, let's now see how to manage the queries and how to actually solve the problem. Now in this case, you know that I will be maintaining 2 query pools. The available query pool will always be recording the options which are available with us. So whenever I am present at an index, I will try to record all the queries which are available with us. So in this case, I have already explained you that we will be maintaining it as a max heap, because I always want to choose the best option in between multiple queries if it is available, right? So in this case, I will be recording Q1, which is from 0 to 1, and I will be recording Q2, which is from 0 to 2. Okay. So once we have recorded these 2 queries, then the next step should be to see what is the value here. It is 1, right? So I want to transform this value to 0. Now once I want to transform, it is better that I don't use the newly present queries, but if I had already included a certain query in the past, then I will try to reuse that as I have previously explained, right? So how will I know if I have already included a query? For that, I will be maintaining a separate pool, which is the used query pool. Okay. So in this case, if you look at the used query pool, it is empty. That means we have not included any query in the past. So that is why if I want to convert this 1 to 0, I require exactly 1 query. And out of these 2 queries, which one is the best option? 0, 2 is the best option. So I will be taking it out and transferring it to the used query side, because this query has now been used. It is now getting used. And since you have used 1 query, you can make this 1 to 0. Okay. Now if you look, this max heap is sorted based on the endpoint. So you can only save the endpoint rather than saving the start point. It is not required. Okay, I will be doing this in the dry run anyway. This step is only to give you an idea. Now, once you are done with this step, then we need to expire all the queries which are ending at this particular index. There is no query ending at 0, so I will be moving forward. Okay. Now before moving forward, another case which would have arrived is this one was 3. If this one was 3, then I would have required 3 queries at this particular index 0 to make it a 0 transformation, right? But do we actually have 3 number of queries? We only have 2 queries. So in that case, it wouldn't be possible to convert 3 to 0. So I would have returned -1 simply. Okay. So I have already written the entire algorithm steps. There are 4 steps involved. and if you read it you will totally understand, but let me give you the idea. Now if you move to the next step, here the first step that we want to do is we need to push all the queries, which will be saving all the available options with us. So I will be saving 1 comma 2 for query 3, and I will also be saving 1 comma 4 for query number 4. Okay, now since this value is 0, I don't need to transform it, right? Now I will be expiring all the queries which is ending at index number 1. So look at the used query pool. Okay, is there any query which was previously used and expiring at index 1? No, the used query is ending at 2. So that is why I don't need to expire anything. Now if you question like why are we not expiring this 0 comma 1, then actually it is not required. Since we are maintaining max heap, the main use case of the available query pool is to get the query which is having the highest endpoint. Okay, so whenever we want to use a query, we will be extracting it from the used query pool, and if the used query pool do not have sufficient number of queries, then I will transfer some of the queries from the available query pool to the used query pool side, right? This is what I will be doing. So while transferring itself, I will maintain that no invalid query is transferred. Otherwise what would happen is if you try to expire this 0 comma 1 on a max heap, the max heap can optimally give you the highest endpoint query. In order of one time you can do the lookup, and in order of log n time you can pop it off. But searching for any random query will require order of n time, which will not be optimal at all, and so this solution itself will become brute force solution, right? So you cannot do that. So simply I will be avoiding this, expiring the query in the first heap, right? Now once we are done with all the steps, I will be moving forward. Now in this case, at query 2, I will be recording all the available options. So what are the available options? 2 to 3, 2 to 3, which is query 5, and we don't have any other option, right? Now I will see, I need to convert this 3 to 0. So how many queries were previously included? 0 to 2 was previously included. So definitely I can convert this 3 to 2 by using an already used query. Okay, so here I don't have to include anything extra, but still we need 2 more queries. So 2 queries needs to be transferred from available pool to the used query pool. So 2 comma 3 will be transferred, and the second best option is let's say 1 comma 4. 1 comma 4 will also get transferred, right? You could have also transferred 1 comma 2, but since it is a max heap based on the endpoint, 1 comma 4 will only get transferred. 1 comma 2 will not be transferred. Okay, now this is the greedy pig solution which I had already explained on first slide, right? Now once you have transferred 2 queries, this value can become 0 now. So 0 array transformation is possible. Before moving forward, you need to expire the queries which are ending at index 2. If you look here, then this 0 comma 2 is ending at index 2. So this one needs to be popped out. So what happens is, whenever we require certain query to be used at index I can simply use this pool size, pool.size, and I can get whatever is the number of queries present, and I can use them to convert the given array element to 0 if possible, right? So getting the size is easy. You can use any data structure, but whenever the time comes to expire all the queries which are ending at an ith index, you need the nearest endpoints. Okay, you need the queries with the nearest endpoints, because what happens if you first get 1 comma 4, you cannot expire, then you don't want to do linear search on all these pairs, right? So it's best that if you can keep this entire structure sorted, if you can keep it sorted based on the endpoint, then you can always say that if you cannot expire 0 comma 2, then you cannot expire anybody else. But if you can expire 0 comma 2, you will try for the next set, and if you cannot expire 2 comma 3, then you cannot expire anybody else. And the best data structure to get that is a min heap. So this min heap will be managing the endpoint. Okay, it will be sorted based on the endpoint. So this used query pool will be a min heap. The available query pool will be a max heap for that reason. Okay, and now I will have to move forward. So when you move to this 2, then is there any query starting? So query 6 is starting at index 3 and ending at index 3. So yes, I can include this. First of all, Q6 will be added as 3 comma 3 into the available pool. Now you see this value 2 and check out what is the number of used query. So the number of used query are 2. That means you can only use the used query and convert this 2 to 0, and no more queries will be required to be transferred from available pool to the used query pool, right? Now you have to expire all the queries at these 3. So see how many queries are expiring, only one query. So you will remove it. So this is the entire process, and using this, if you track the count of how many number of queries did you actually transfer from the available query pool to the used query pool, then this transfer will tell you how many actual queries were used. Let's say T number of queries were used. Total there are Q number of queries. Then Q minus T will be the queries which you never used, and this will be the result. I hope you have understood the entire idea and why we are using a max heap on the available query, min heap on the used query, right? So you also know that I am just tracking everybody by just the endpoint. So I just need to maintain endpoint and no start point would be required. So let's see the dry run using the max heap on available query and min heap on the used query. So I'm taking the exact same example 10321 and I have marked all the queries. So this is already sorted. Sorted on start point. Now I will be starting with index number 0 and I will be tracking all the transferred queries from the available query to the used query by using a applied counter. Now how many queries are starting at 0? There are 2 queries, 01 and 02. So both of them will be recorded as 1, 2 into the max heap, because I am just recording the endpoint. The start point is not important here. Once you have recorded it, the step number 1 is done. In the step number 2, we have to reuse if any query was already included. Okay, so in the used query part, you have not included any query in the past. So there are no available queries which can convert this 1 to 0, right? Which can reduce this number. So this step number 2 will not affect in this particular iteration. Step number 3 was if more query is required, then get them from the available pool and push them into the query pool. That means if you require more query, then you need to transfer some query from the available to the used query side. Yes, I need one of them. So which option is best suited? You know that the query which is ending later should be the one which is transferred. So you have done the transfer. One item is transferred. Applied count will increase by 1. That means you have applied one query. And you just required one of them. So this becomes 0 and we are done. Once we are done, at the last step, we have to expire all the queries which are ending at the ith index. Okay. Another condition is if we had insufficient queries, that means if a certain value could not be converted to 0, that means we had less number of queries available, then I need to return -1 at this step. But that condition is not present in our example. So we need to expire all the queries ending at ith index. So for expiry, you look at the min heap and you see, is there any value 0 here? No value 0, right? So nobody will expire here. Move to the next index. This is index number 1. What are the queries starting at index 1, 1, 2 and 1, 4. So save 2 and 4 into the available query pool. Okay, we are done. Now we cannot add this one because this starting point 2 is higher than index 1. Now how many queries are needed? 0 queries are needed. That means I do not need any query at this point. Now how many queries are expiring at this index 1? Well, from the used query there is nobody expiring. So I just care about the used query. Since nobody is expiring, I will move forward at this index 2. Now at this index 2, I will be including 2, 3. That means I will be inserting 3, only the endpoint. Now how many queries are required here? 3 queries are required, right? So how many are actually present in the min heap used query? 1 query. That means I can convert this 3 to 1 by using this used query. So this will not incur any more query applied because this is the same query which was applied for index 0. Okay, so applied count will not increase. But since I need 2 more queries, 2 queries have to be transferred from available query to the used query. Which one will be transferred? The 4 will be transferred because this is ending later. And then the 3 will be transferred because that is also ending later, right? So after transferring 2 queries, 2 operations are applied. So applied counter will increase by 2. So this 2 will become 0. And now we will have to expire all the queries ending at 2. So there is only 1 query ending. This is a min heap. So 2 will be on top. We will be removing it. Next item 3 is larger than 2. So it will not end. and I will move forward. When I'm at 3 comma 3 is starting, so I will push 3, which is the endpoint, and we are done with all the queries. Now how many queries are required here? 2 queries are required. What is the size of used query? 3. So since this 3 is greater than equals to 2, this can be converted to 0 by reusing the queries, right? So no more extra queries applied. And how many queries are ending at this 3? Only one query, so I will be removing it here, right? I'm just looking at the used query, not at the available query while expiring. And now we need to move forward. When you move forward at 4, there is nobody starting at 4, and the queries required are 1. The used query size is also 1, which is greater than equals to 1. So I can reuse the same query and convert this to 0. No more extra queries required. And at this point, if I want to expire, this one query which is present will expire and we will move forward. So we are done converting this entire array into a 0 array, and the applied count 3 means we have used 3 queries. What is the query's size? So query dot size is giving me 6. That means 6 minus 3 equals 3 queries were unused. So that will be our answer. So I hope this entire approach is clear. If you follow, step number 1 was to sort all the queries. So sorting all the queries will take q log q, thinking that q is the number of queries. Then I am iterating for all the position, and there are n such positions from 0 to n minus 1. And for each of the position, I am pushing and popping the items which are actually storing the queries. So I will take log q for that, because it is storing the queries, right? And in the worst case, all the queries can be present in the heap. So it can be 2 times log q, because you are pushing and popping and again pushing back into another heap probably. So it is a constant time. So I'll just be taking order of q log q plus n log q. And if you consider the space complexity, we are using order of q. Q can be the size of the max heap as well as the min heap. So I hope this idea is entirely clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the nums array and the queries. So first I will be finding the num size, and I will be taking a min heap called the used query and a max heap called the available query. I will be sorting all the queries as explained, because I will be moving from left to right. So I'm sorting it in ascending order based on the start point. I have explained all the reason why we are doing that. Then I will try to process all the points. So I'm taking a query position just to keep track of which query we are looking at. And I'm taking an applied counter, which will be counting the number of queries which have been applied. And I will be iterating for all the indices in the array, in the nums array. Now first of all, whenever I reach to index I will be saving all the queries which are starting at that particular index. So this is that step number 1. Then step number 2 is to use the already used queries. So maybe if I am at an ith index, there was already used query. So if I used the already used query, then that will not incur extra cost for including the new queries. So that is step number 2. Then in step number 3, we need to check if I need more number of queries. Like let's say the value was 2 here and I had only included 1 query in the past, then I will require 1 more query. So for that reason, I will be going through the available query pool, and I will be taking out the available query and pushing it back into the used query and decrementing the value. As soon as the value becomes 0, I will be breaking it out, and always I will be incrementing the applied counter, because once I am transferring the queries from the available pool to the used query pool, then I am actually going to use that query, right? So that is why the applied counter will increase. After you are done with it, you need to check if the num size is greater than 0. That means you do not have sufficient query available to make it a 0 array, and that is why you need to return -1. That particular value cannot be made 0. Otherwise, if you have number of queries greater than equals to the num set I, the num set I can always be reduced to 0. And so the last step, which is step number 4, was to expire all the queries from the used query pool. Okay, at whichever query are ending at this ith index, remove them from the used query pool. Do not do anything to the available pool. Okay, so after repeating this entire process for all the elements, if you can convert all the elements to 0, that means zero array transformation is possible. And at the end, take the total number of queries and subtract the applied count number of queries to get the queries which you never applied, and that will be your answer. So I hope this entire approach is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.